Hi everyone and welcome back to PrepFusion. I'm Anish and today we'll be solving all the network theory questions from the GATE 2024 IN paper. So in the IN paper, total 5 questions came from the network theory. So mainly the weightage is around this 5 to 6 questions only, and thus for marks wise it will be around 8 to 10 marks or 7 to 10 marks. So generally the weightage is between for network theory for EE, EC and IN is almost 7 to 10 marks. Okay, obviously this network theory will be used in other subjects other subjects as well, so that's why the weightage is like this. So the questions that for IN came up were pretty straightforward and like simple only, not that much difficult. So let's start with this first question. So here you have to find the power, voltage supplied and current drawn is given. You have to find the average power absorbed by the circuit. The voltage and current is given. So in this case you have to use the concept of orthogonality. So whichever signals are orthogonal to each other, then their area will be zero. Basically we're multiplying this voltage and current. So if two signals are orthogonal with each other and we are integrating, right, for power we integrate V and I with respect to time. So we're integrating these two signals, then if they are orthogonal to each other, voltage and current are orthogonal to each other, then what will happen? Then that integration will be zero over a time period. Hence like the signals that are orthogonal, the voltage or current signals that are orthogonal, they will vanish. Only the signals which will be not orthogonal, that is basically the angle is not a multiple of 90 degrees, then those signals will contribute to some power, absorb power or deliver power, but other signals won't contribute. So here in this case what do you see is that this 95 has phase what? Zero. Like this has no frequency is zero for it, and everything else has some frequency component with it. So when these has some frequency, right? So this is zero frequency, so it is orthogonal with all of these signals. If you integrate, you just derive for yourself, you integrate 95 times 4 cos 120 pi t minus 60 over a time period for this is this, right? 0 to time t. Okay, you will see the area is 0 because this is a cos function. Simply cos function, like area over a time period is 0, so that's why. So this will always give me 0 area. Now which are not orthogonal, what we can see is this is 120 pi and this is also 120 pi. So the frequencies are same over here, but the phase difference is 60 degrees. So these two signals are not orthogonal, so this will contribute some power. What is the value of the power? It is simply Vm upon root 2 into Im upon root 2 into cos phi. So Vm is 200 upon root 2 into Im 4 upon root 2 into cos phi. Phi is 60, cos 60. Okay, then what next is happening? Then we have this thing, right? This is 360 pi t and this is 240 pi t. Again they are orthogonal. If you just integrate these two, multiply these two or multiply these two, whenever the frequencies are different, that means they are orthogonal. That is simple. So these two are orthogonal with each other, hence the area contributed with the multiplication will be 0. We'll only get these component, so the power absorbed will be answer only this. So this will be simply 200 into 4 divided by 2 into 1 by 2, which is equals to 200 watts. Okay, so the answer to this question will be 200. Now let's go to the next question. Again like pretty basic question only. You have been given a circuit and it is told that the switch in the following figure has been closed for a long time. So t less than 0, the switch is closed, okay, for a long time. So let me draw the circuit for t less than 0. This is t less than 0. So for t less than 0, this is reach steady state, so this will be short circuit. Okay, and switch was closed. Okay, and if switch was closed and at steady state, capacitor will be open circuit. This is 12 volts. And this is 4 ohms. Okay, so what is the current through this? The current through this will be simply 12 by 8, which is 3 by 2, 1.5 amps. Current through this will be 1.5 amps. So IL of 0 minus will be 1.5 amps. Okay, this is one thing that is fixed. Now what is the voltage across this? The voltage across this will also be fixed. The voltage will be simple, the voltage division. 4 and 4 are same, so this will be simply 6 volts. So Vc of 0 minus will be 6 volts. Now you draw the circuit for t equals to 0 plus, as you have to find the dvc of dt. Like whenever you are asked to find dvc of dt or dil of dt, you remember one thing, that like you write try to write the KVL equation of the current and voltage for capacitor and KVL equation for current and voltage for the inductor. So what we know, IC of t equals to C dVc by dt. Okay, now if I write this, IC 0 plus divided by C will be equals to D dVc by 0 plus by dt. Okay, so yeah, this is what we have to find. So simply if I find the current IC 0 plus undivided by capacitance, then this I will get my answer. So I have to find the current at t equals to 0 plus. So at t equals to 0 plus, the switch is getting opened. So if the switch is getting opened, then the circuit will become something like this. So t equals to 0 plus, inductor obviously won't change its current instantly. So this will be 1.5 amps. And obviously this is 4 ohms, but here zero current will flow because this is 0 amps, and this has some voltage plus minus 6 volts. Okay, initial capacitor voltage is 6 volts. It won't change its voltage instantaneously. Capacitor doesn't change its voltage instantaneously, and inductor doesn't change its current instantaneously. And this is 12 volts. But what we are interested in the current through the capacitor at t equals 0 plus, which can change instantly. That is not an issue. Capacitor can change its current instantly. We are interested in this. Okay, so like as the normal notation of KVL is, IC should be incoming to this plus minus terminal of the capacitor, as they have given. Where did it go? Yeah, so plus minus, it should be incoming. So it is incoming, so IC is positive in our case. So like let's see if it's positive or not. So this is 1.5 amps, and this will flow here because through here zero current is flowing. So IC 0 plus will be coming into the positive terminal as 1.5 amps. So again I will put this in this equation. So 1.5 and capacitance is 0.1 farad equals to my dVc 0 plus by dt, which is equals to 15. Okay, so 15 will be answer to this question. Very simple. So yeah, 15 will be answer. And next question, this is again on simple like network concept. Okay, that the RMS value concept. So you have been given this I of t, and you have to find the root mean square of I of t. So here again the orthogonal thing will come up. So the whichever signals are orthogonal to each other, just the RMS values of individual and squaring them individually, and then adding them up, then doing the overall under root of them, that will give me the overall RMS value of this signal. So what do I mean by that? So individual RMS values. So overall IRMS will be the square root of the individual RMS whole square of the orthogonal signals. So obviously these are all orthogonal, right? Why is this orthogonal? Here we have 90 degree phase shift, right? That's why here we have 90 degree phase shift. Okay, here this is again different frequency. That's why again between these 3t, sine and cos, we have 90 degree. Sine and cos have 90 degree phase shift. So these are orthogonal signals. So that's why I can simply do the RMS. Okay, so now what will happen is that this will be 4 square, because this is obviously orthogonal will everything 4 square. This, and the RMS of this is 4 itself, because it's a simple 4 constant value 4 DC value 4. So this will be 4 square. Then the RMS value of this will be 30 by under root whole square. So 30 by under root 2 I meant, and whole square. This is the RMS of this particular signal, and the square of this I'm doing, and I will do the same for all of the other signals. This will be 20 by under root whole square plus 50 by under root whole square plus 10 by under root whole square. Okay, 10 by under root whole square. So what will be the value for this? So they have told us to round off to 1 decimal place. Let me just do the calculation for this. So this will be 4 square plus 900 by 2, which is 450, plus 400 by 2, 200, plus 225 by 2, 2.5, plus 50, and this is 16. So this will be almost equals to 16, 500, 500, 700, 700, 812.5 plus 16 under root 28.78. So approximately we can write it as 28.8 because they have told us to round off to one decimal place. So the answer to this question will be 28.8 amperes. Okay, so now let's go to this next question. So this question is very interesting because they have told us that the galvanometer in the circuit has zero deflection. So what will be the value of Rx? So this is looking like a bridge circuit, but this is not really a bridge. So here we have resistances here. So now what should we do? Basically, let's first see one thing that in the first time this may not click. So what you can do is you can just mark for review and then go solve other questions. Then again you come back to this second time this may click. So you have to make current 0 over here. Okay, fine, current is 0, so this I can totally remove. Okay, I know that they have given the condition the galvanometer has 0 deflection, so I can remove this. Current is 0, so let me draw the circuit. Current is 0. $60, 60, this is 40, 40 and 60 and 90 and Rx. Okay, so Rx 90, 60, 60, 40. Now what do we observe is we need to have like the potential at this point and this point needs to have same potential, then only the current through this will be 0 because galvanometer is basically a resistance itself. So but before that, how do I find the potential here? One thing I observe, this is like also a bridge circuit. If I just identify this circuit in isolation, why? Because here I have two branches and here also I have two branches, and in between I have 60 ohms. Now is this bridge balanced? So if I see one thing that yes, this is balanced because 40 into 60 and 40 into 60, the products are equal of opposite diagonals. So this bridge is balanced. So simply I can remove the 60 ohms. I can remove the 60 ohms or I can simply short the 60 ohm. Okay, whatever you want to do. Remove this, open circuit this or short circuit this, it doesn't matter because if the current through this is 0, then the voltage is also 0, whichever way you do. Okay, so yeah, basically you remove this or short circuit this, it doesn't matter. So now what will happen, this 100 and 100 will come into parallel. So or what you can do is you can short this also. Okay, so I'll short this now. So this 40 and 40 will come in parallel and this 60 16 will come in parallel. 90, 20 and this point is 30, 60 by 2, 40 by 2 Rx. Now again what you can do is you can make the opposite products equal because here we have a galvanometer and this is also a bridge circuit. So here Rx into 30 should be equals to 20 into 90. So my Rx will be simply equals to 60 ohms. Okay, you can do it like this. So this is how you can do it. And is there any other way to do this? I'm just thinking that is there any other way to do this? So if I simply just short circuit this, no, we won't be able to do this because like if I what I was thinking is if I open circuit this, then will I be able to do this? Then no, because I have to find the potential at this node, right? I have to find the potential at this node because the potential between these two nodes should be same, then only no current will flow. So if I just open circuit this, then I find the equivalent resistance. This will be what, 40 plus 100, 40 plus 40 plus 60, 100, 100. So 100 parallel with 100 will be 50 ohms. Then I won't be able to tell anything because I don't know that how much is 50 ohms of this is in this side and how much 50 ohms of this is in the right hand side. So the best method will be just to short circuit this and then use the equivalent bridge method. Or again you can simply solve like this also, that you don't need to equivalently solve this. What you can do is you have known that yeah, this you can remove the 60 ohms, then simply you apply the bridge concept in here. So if you apply the bridge concept here also, you will get same. So Rx into 60 and 90 into 40, you will fetch the same answer. So Rx into 60 equals to 90 into 40. So that's how you solve with open circuit, and short circuit I already shown you. So here Rx will be equals to, so this I can write like 2 3, so this will be 30 into 2, which is 60. So yeah, either way, you open circuit or short circuit, you have to make one thing concept clear, the concept of Wheatstone bridge, which is the potential at these two, like these two nodes should be same, or these two nodes should be same. That is the important point of the Wheatstone bridge concept. So these were a few questions. Okay. We have another question I forgot. Okay, this is again another simple question. They have given you two magnetically coupled coils when connected in series aiding. Series aiding means the mutual flux between them is aiding them, so overall inductance will increase. That means if I have a coil with inductance L1 and another coil with inductance L2, the mutual flux with them will aid them. So flux is aiding both of them, so the mutual inductance will get added to M. Okay, this will be the L equivalent of series aiding, and configuration have total inductance equals to 500 millihenry. Okay, this is given. Then when connected in series opposing configuration, the coils have a total inductance of 300 millihenry. So L1 plus L2 minus 2M equals to 300 millihenry. Okay, so now what you do now, basically another thing is told that if the self inductance of both the coils are equal, so L1 equals to L2, L1 and L2 are self inductance equals to L, then the coupling coefficient will be, now there is a formula for the coupling coefficient where M equals to K under root L1 L2, where K is the coupling coefficient, so K will be equals to L1 and L2 are equal to M by L. Okay, so just a simple solve only. So what we can write this as 2L plus 2M, so L plus M will be 250, and here this is 2L minus 2M, so L minus M equals to 150. Simply just subtract and add, so 2L equals to 400, L equals to 200, and M equals to 150, 250, 150, 100 and 50. Okay, this is in millihenries, everything is in millihenries. So what will be K? K will be simply equals to M by L, which is 50 by 200, so which is 0.25. Okay, so not much to discuss over here. So the answer to this question will be 0.25. So these were all of the questions that I found from IN. Okay, next I will try to solve like PYQs of different subjects. So that's it for this video. Thank you for watching, and I will see you in the next video.